Hey guys, this is Leonard from Lenco Solutions, and it's been quite a while since I made the last video, and as you can see it's because I've been very busy. So I would like to share with you what happened so far. So yeah, this is what we came up with, and as you can see it's disgusting because I've been sending it over the trails. I really like it a lot, and quite a lot happened. So we are now on the 7th version of a board that I made, and what's new compared to the latest one, which was the V6, is obviously the roll suspension. I feel like I should dedicate a large portion of this talk to what that actually is. And as you can see, this is a 5-inch motor with a BTG tire, so the latest Pioneer from the Float Life. It's really good, I really like it. I think it works well in this combination, and I would like to show you a few things. I'm going to show you in cut the design of the motor, the design of the frame, the way it works, and yeah, in general, what's cool and new about this motor in particular. I'll briefly explain roll suspension first, and then I'll dedicate a bit about the 5-inch motor. So the 5-inch motor is compatible with all the XR builds. You need special bolts for these blocks. Other than that, that's it. I supply them with the motor. Because it is quite a complicated motor to put a tire on, it's probably best, if you want this, that you send me your tire and I put it on. I'll explain later in the video why, but basically you have to assemble the motor inside the tire to make it fit. The benefit is that it's using the same exact stator and the same exact magnets of the 6-inch, which will end up with you having the same amount of power as a 6-inch Lenco motor, and then also same thermals. One other thing that changed is that, maybe, I don't know if you can see it, but the blocks are a bit bigger now. It's just to make the axle stronger. It's not that there were lots of issues with that, but there was one issue with it. It was probably due to an imperfection in the material, but to avoid taking any changes in chances, I did change the blocks, and then I sent out blocks to pretty much everyone that had a Lenco motor before. If I haven't, please reach out, because I'll get you some new blocks. I think they'll look a bit better also. And it's basically making the drive shaft twice as strong. So good things. Other than that, it's the same stator, same shaft, same magnets, same outside. I'll just show you in a bit how I was able to stuff this in a tire. This is the foot pad you can use with your flight fins. Also some changes were made to that. I've been working with Gareth, who's also in the Stoke Seekers group, and he wanted a light in the foot pad to show you the battery percentage, and also showing stuff like duty cycle. The code is still being worked on, but this is the prototype for the foot pad. So it's based on the Lenco original foot pad with the extension, because I really like to have flight fins on my foot pads. This is one solid print, and at some point I just watched one of Jeff's videos from the Float Life, and he liked this stance where it's kind of like 45 degrees. So I went with that, and it turned out to work really well for me. And the rear one is almost straight, it has like 5 degrees in it. And then later on I added this light. Yeah, so let's talk about roll suspension. Basically what it does, it allows this tire to rotate in this direction, so the tire can roll like that without actually moving the frame. It's a bit hard to show you in real life, so I'll show you in drawing program in CAD. And these dampers are basically working against that. And what it does in practice for me is, one, it allows me to lean more into the corners, because the board will arc like that while the tire stays upright, which means you create more lean angle for the body, and especially on high speeds I think that works well. What it also does is, say you hit like a pothole on one side, the board tends to roll out on you, and like that. And this is now being dampened by some actual dampers, so this effect will be less profound, which will mean in practice that you have much more headway like that. So yeah, it's doing things like that, and basically it makes you feel like you're actually riding more on a cloud, so it's more floating than before, which is great. And then you can just really sand it, and the board is really more capable of compensating for like the terrain, for the chunk. So yeah, that's great. Also this 5-inch motor makes you go over chunk a lot better. So yeah, the combination is quite wild actually. You can really send it. And then on this design I was using the sliding battery box, which at first looked like a great idea, and then I was thinking about it and I didn't really like the idea anymore so much, because the frame was really based on that box, because I thought you really needed it. Back then I also thought you needed like these dampers to be on both sides, and then later on it turned out you only needed them on the front, because that's enough force, and the inner frame is perfectly capable of transferring the forces, which gave me the space on the back side to change the frame. So this is actually a version with a sliding battery, and I made a few actually, but then I changed the design to make it fit a torque box. And as you can see in this design, there's no bolt holes here for the actual suspension, which were here, but now it is changed slightly to make this inside a bit wider, and that makes sure this torque box fits. Yeah, so I think it is not really making it more expensive, but it will make you able to use a lot of more batteries, and compatibility is really the key here. You do need a special gland. I will provide this with the frame kit. It fits inside the torque box or whatever if you just use the same diameter, and it's basically a TPU printed part with a ring over it on this side, and then on the inside you press in a ring which secures it, so as long as your battery is not coming out, this gland is not coming out. And I tested it like under a stream of water, and as long as you don't submerge it, it's pretty watertight. So I think it's plenty. And then also the frame is actually in front of the gland. Can't really see it like that, but the gland is here behind the actual cage, so there's not much spray actually going on this gland. So yeah, I think it's plenty. Here you can see the bearing, which might be interesting for the roll suspension. So this is the bearing stop. A bearing goes over here, which basically allows the frame to rotate like that. But yeah, I'll show you more of that in CAD. Recording my screen just by pointing my camera at the actual screen, so apologize for the quality, but I think it's kind of ridiculous that I have to pay so much for a screen recorder, and that all it does is just record actually what I'm seeing. And I still wanted to make the video today, so here it is. So here is the actual design of the V7 frame. As you can see, I put just a random motor in it and some battery box I designed quite a while ago, just to show you what it does. Right, so now I can just show you, this is actually the way the frame will rotate. This is obviously very exaggerated. In practice it probably won't do more than 10-15 millimeters like that, which is already doing a lot, but this does allow you to see what's actually happening. So yeah, there's two bearings on this side and on this side. And as you can see, they are mounted on this stub, right? The stub that I just showed you on the part which contained the torque box. And then the motor is actually inside this like cradle, and this is all made out of sheet metal in stainless steel, and there's a fishtail weld here for maximum strength, and you weld it on both sides, and it's actually not the worst spot for the tension in there. Yeah. You can see the blocks. The cable for the motor comes out of this hole on the block. It passes through this hole on the cradle, and then it goes into this hole where your front box will sit, which is connected through the gland and going into your box. And you gotta leave some extra length, and there's a clip inside this hole that will stop the cable from rubbing, and as it's not moving that much, it seems to be working fine. There's actually 3 degrees in the frame right here, so you could measure like this face to this face, and it would show you that it is a few degrees off, right? So you want 180 degrees would be like a half a circle, so you got 3 degrees on each side, giving you a slight angle. Other than that, the tire does sit in the frame square, so it will give you a lot of clearance, and clearance is good to get over a lot of stuff, right? And then yeah, there's a battery box in here. Just gonna close this measuring thing. Yeah, so this is the gland we discussed. Don't know if you can really see it like that, but this is the TPU printed part. This is the ring that goes over there. And there's like, it sits like in a groove. Because the TPU is flexible, you can get it over the gland and get it to sit in the groove, because it can flex to the inside. And then you push this tube inside, which will lock it in. And then obviously once the battery is in, this tube can't slide out, because this is where the battery is, so it will never come out. And it seals it just because TPU is like a rubber being pressed in there. So yeah, that's basically the design of the frame. Your wiring harness will go in this channel, and you could say how come it doesn't rub on anything. Well, there's like 4 clips in these holes, keeping the cable firmly in this channel here, keeping it away from everything. And then the center cradle is what's taking the initial torque of the motor. Obviously these 2 bearings are what is carrying the load. So all the load in like the Z direction, for lack of better words, is being carried through these 2 bearings, and then this side plate only needs to deal with the torque. And normally when you have your blocks in the middle and you're standing like on the edges, you have like an arm going from this point like to where your feet are, but now that is only half, because the inside frame will transfer the torque from the center of the block to the bearing, and now you only have the distance between this bearing and the center of your feet. So yeah, that's reducing it a lot, so it's not like there's the normal torque going through this outside edge, which allows it to be thinner than this inner cradle. This is 5mm stainless, this is 3mm stainless, so still pretty a lot stronger than aluminum. And then on the front you bolt both this quarter and this reaction plate in this part like that on the side, and then on the back, because you don't have space for that due to the battery box being wider, you bolt it in from the top and the bottom, because obviously you don't need that damper assembly on the front side connecting that. There's a few holes here which are meant to create a fender. I hope I can design something that fits that, because right now this is still work in progress. We can spin the tire a little bit. Yeah, so that's basically the V7 frame explained. Let's talk about this 5-inch Lenco. Here you can see the full design. Maybe you spotted that this tire was based on the Vega, which I found somewhere on the internet, and I just stretched it a bit to make it work, because obviously there's no Vega in this dimensions. It seems to work for me. If you find a model of the Pioneer, let me know. We can swap it out. But yeah, for basics it works. And on the outside it looks like a motor. You probably never know what's inside. Just that there's no bolts on this side, so the only clue you would have of disassembling it would be the bolts on this outside shield. You would also have to remove the axle blocks, but I'm going to show you a section cut which will explain a lot more in my opinion. So let's do that right now. So as you can see, I just cut the motor in half, and you can see the full inside of this motor. And as it is many parts, it takes a while to render, so let's give the machine some time to catch up. I'll talk you through the parts. This is the shaft of the motor. This is where the blocks go over, where the bearings sit on, what is basically transferring all the force from your weight to the bearings and to the rest of the frame. Then here obviously are the axle blocks. This is also where you can see what I updated when we had an issue with the shaft. The old blocks would sit up against this face, and now it is wider, so it will include this part of the shaft. As you can see, the section cut here it's a lot thinner than here, so yeah, this will give you a lot more flesh to resist stuff happening with the shaft. This is also nice to see the design of the Lenco, because we're using a lot smaller bearings, which are very common bearings, which makes them a lot cheaper, and also your rolling resistance will be a lot less. And then to seal the shaft from the elements, we're using a normal oil seal, which has a dust seal on the outside and an oil seal on the inside. Obviously there's no oil behind it, but it is sealing it in a regular way. Also a very cheap part, they're like a few euros. It seems to work really well, and it's cheap. You can also see that there's some space between the bearing and the housing, and this is just because it needs shims on the inside, because it needs to be like perfectly aligned. So as you get small manufacturing defects, you're gonna have to shim out every motor that you create. So basically what you do is you fit it dry like this, you move the shaft to one side, put a measuring device on it, and then move the shaft in the other direction, measure the amount the shaft was able to move, and then grab shims in the same size, and then maybe divide that left and right so the stator is actually sitting in the middle. And this sort of green part is the iron plates stacked, so that's like your stator core, which has windings around it, but for the simplicity I just made this simple model. Over here you can see like this part, that's the magnets, and the magnets sit on this hub, on the hub body, let's say. This is what I called it. And there's no bolt holes in this hub whatsoever, and that is because the only way to get this size hub body, let's say, through the hole of the tire is to not have a flange with bolts on it. So what's actually holding your Lenco together is the bolts going, so this is a bolt right here. Let me just turn off the tire real quick and then show you the outside. So here's like, there's 8 bolts now connecting this flange to this flange, and it's compressing this against this hub body, and it's just compression force keeping it together. And then you may have noticed that your tire is actually sitting on this face and this face, which will seal against these faces. So air could potentially escape between the pocket here, going into the stator and then out somewhere. So there's an O-ring inside this to prevent this from happening. And as you want as much like meat, like as much aluminum as you can, I put this O-ring groove in a 45-degree angle. If I would put it directly like that, it would come in a lot more, and I wasn't comfortable with the amount of aluminum left. And if I would put it on this way, you would have a similar problem, as you wouldn't have enough surface area for the compression force of both halves. So I ended up making it 45 degrees like that, and it seems to work really well. So yeah, this kind of tells you why you have to assemble it that way, because there's no way to do it any other way. So to assemble it, you first grab this part and you can put it in a tire, and it's very similar to like a normal way you would put it on a tire. So this flange can just go in the hole, you put the sidewall of the tire in this groove, and then you can just slide it over. It's very doable. Then you grab your stator, which is already inside this hub body, which has no bolts on the outside, no holes, and you just slide it in, and the axle will go into this hole. You need to grab the side with the electrical cable. The whole assembly will just go in, and then you can see this is a separate part, which is like, I call it a bearing shield, because it contains the other bearing. You can just slide this on the other side of your tire. It will just slide in. There's a lot of room, especially on the big tires, to get that in. And this flange will not be there at this moment. So as you can see, there's a lot of access to these bolts. And you can even, I'll make a separate video of assembling a motor. It's actually not a line. But you can kind of imagine you putting like all these 8 bolts through and through in holes. There's a lot of access for it. You can clearly see the holes and line up everything. At first I wanted to make like a spiral that goes inside that was 3D printed, so it would align everything, but turns out it's really not necessary. And then you basically assembled your motor inside. It slides together quite well. And then afterwards you have to attach that cover, this one, and this is a very easy step. It just slides over this part, 8 bolts again to fix it. The O-ring's not quite aligned, but you can see that the O-ring will fit into this groove, which will press against the other shield, sealing everything up, because obviously the tire is here, the air could go through here and go outside. And once you've done that, you can just normally inflate it. It will set the bead, and it will just work like a normal motor, but you would have the same strength as a 6-inch motor. So I think that's pretty cool. I really like this idea. Yeah, if you really want a 5-inch motor, I think this is a good option, because potentially it could have what you need in terms of power and thermals. So yeah, consider it. Let me know what you think. If you have any suggestions or concerns or questions, let me know. I always try to at least consider it and get back to you on that. So yeah, that's the 5-inch Lenco. I hope you enjoyed this video. I hope it kind of explained the way it works. If you can, come ride with us in Utrecht. You can test it, share it with your friends. If you have any questions, leave it in the comments. I will try to answer them. And yeah, enjoy the stoke, guys.